Welcome to the Byrne-Wheeler Report. I'm Joe Byrne with XPU.pub.
And I'm Bob Wheeler with WheelersNetwork.com.
Before we begin, we haven't settled into a regular schedule, so please click the bell icon to be notified when we release a new video. On the agenda for today, OCP news and the AMD OpenAI deal. So, Bob, you attended OCP. What was the big news at that conference?
Yeah, it was, first of all, it was a big event. I think the attendance was pushing 11,000 this year,
Whoa.
up from 7,000 something last year. So it's it was very crowded, very busy, and as usual, a ton of content, more than one person can possibly cover. But I think the biggest news really at the show was the AMD Helios rack on the floor, and then Meta's related rack. So Meta introduced something called the Open Rack for AI, and this is using the Open Rack wide form factor, which is essentially a double wide rack.
Okay.
And so this is the same as what AMD previewed back in June for the Helios rack, where they talked about kind of the high level specs. But on the show floor, AMD actually had a physical rack sitting there at the front of the booth, and there was a crowd around it for a good portion of the expo hours, and similarly the Meta booth had their equivalent rack. And so
Could you see the innards of the rack or just like the external rack and shelving, but nothing was
it
pulled out?
was mostly the external part. I do have a figure of the compute tray for Helios that just kind of shows the layout of the GPUs and the CPU, and we can take a look at that. But I think it brought home that this rack is, a lot closer to reality, even though it's not going to ship until kind of late 2026 timeframe. AMD's developed this as a reference design to roll out to ODMs and OEMs, and so it was kind of the big coming out for Helios. And
Hey, I have a question. Oh, go ahead.
yeah,
I was just going to say, why did they go double wide? Is that to get more logic into a single tray, or is it to spread the power load over a bigger footprint, or what?
I think it's to ease the design, particularly for the scale up fabric.
Right.
I think that was a major challenge for NVIDIA's rack, their NVL72 rack, and so by spreading things out, it makes the kind of the back plane, which they haven't really disclosed in any detail, but it should make that quite a bit easier. The other thing is, I've heard multiple times now from NVIDIA and others that space is really no longer the constraint in data centers. It's really more about power and sort of secondarily
Right.
cooling. And so there's kind of no reason not to relax the form factor a bit if it eases the electromechanical design and other aspects of the design. And yes, they can probably push the power level up higher in this form factor as well.
But they lower the power density, or per square foot, I guess, by amortizing that power over two racks.
In the near term, yes, but I think it gives them another generation of where they can go to, MI 500 or whatever it is, and the power is likely to increase substantially.
Mm-hmm. Okay.
People are talking about 600 megawatt racks, so that's kind of where we are.
That's that's a lot of power.
Yeah, I mean, compared with 120, sorry, they say megawatts.
Yeah, you said megawatts.
Yeah, yeah, not megawatts. Okay, cut.
No,
Put
we'll
that
leave this
again.
in. This is too good. Or to put it in the
Um,
blooper reel.
People are talking about 600 kilowatt racks, which compare with
Okay, there we go.
120 kilowatts for the NVL72 rack, known as
Right.
Oberon. So it's a big uplift from a power perspective.
That is, it's, even if we were talking kilowatts, it's hard to fathom that much power. But
Yeah,
we've got kilowatt chips, so, you know, you're going to get big racks.
exactly. And they're only going to get more powerful. The chips just keep getting more and more power hungry. So anyway, AMD's messaging was largely around open standards and pushing open standards across scale up interconnects, scale out interconnects, the CPU to GPU connections. They kind of want to portray this as being an open platform, although some of that is still kind of a work in progress. But
Well, it only makes sense if there's an alternative uh, technology foundation using the same standards, right?
yep. So that's kind of the news in a nutshell in terms of the Helios rack.
Okay. And then Broadcom had a new NIC there, right?
Correct. So Broadcom announced Thor Ultra, which is an 800 gig NIC for scale out, for AI scale out or back end networking.
Right.
And there's two things that are new about it. First of all, it's the first 800 gig Ethernet NIC. It's because NVIDIA's ConnectX 8 actually doesn't support 800 gig Ethernet ports. It supports 2 by 400. So even though it's
Ah,
800 gigs of throughput, it's 2 by 400.
okay.
More importantly, though, I think Thor Ultra supports Ultra Ethernet, and thus the name. So supporting Ultra Ethernet consortium specs means that you have a path to standardizing your AI network for the back end or scale out side of the network. And the only other vendor that had announced an Ultra Ethernet NIC was AMD with their 400 gig generation NIC, which is now available, which has a programmable pipeline, which is why they were able to support Ultra Ethernet. But
That's the Pensando based NIC, you're
correct
saying?
from Pensando, and so Broadcom Thor is more of a traditional NIC design. There's no sort of P4 pipeline in that design. So it should be lower power, although I don't think we have a power number yet for AMD's equivalent.
But the Pensando technology is still part of the Helios rack. It's just being used elsewhere, right?
The Pensando NIC is part of AMD's Helios solution, and no, it is being used in the AI backend, but the version that will be in Helios is the forthcoming 800 gig NIC, and so that product isn't available yet. Whereas Broadcom just announced, that Thor Ultra is sampling.
Okay. Anything else about the Broadcom NIC?
Yeah, I mean, I think it'll be the lowest power 800 gig NIC that's UEC compatible. It's probably comparable to NVIDIA's ConnectX 8 from a power perspective. So I think
Okay.
that will become important down the road. And I think it's important to point out that Helios is kind of a reference design. And so customers may have different configurations of the rack. Meta's rack could use a Broadcom NIC instead of the AMD NIC, for example. So
Right.
it's going to be a design that's meant to be disaggregated and flexible in terms of customer configurations.
Okay. Anything else at OCP?
Well, so all of this kind of ties into what's happening on the networking side at OCP. So some months back, Broadcom had contributed their scale-up Ethernet specification, known as SU, to OCP. And then more recently, OCP started a work stream called SUET, which is basically a transport protocol for scale-up Ethernet. And at the OCP Summit, they announced ESUN, which is Ethernet for Scale-Up Networking. And so the idea is that ESUN is essentially layer 2 and layer 3, and SUET is the transport protocol. So the ESUN is sort of what you would implement in your switch, and SUET is what you would implement in your XPU. And so they're trying to create a clean demarcation between the network and what IP you'd be integrating into an XPU. So if you kind of take the Broadcom SU spec, it's kind of breaking it in two and then providing a path to making it more of a true standard. And I guess the most interesting thing is now with AMD using what they're calling UA link over Ethernet, that could be standardized in this SUET work stream so that UA link over Ethernet becomes another flavor as opposed to native UA link switching, right? So now you could have the UA link protocol going over either Ethernet or the native UA link protocol at the lower layers. And so it gives some
And that protocol is
optionality.
like okay. And so that UA link protocol is an alternative transport layer, or is within the SUET transport?
Well, so SUET is just getting started, and so they haven't actually defined it yet.
Okay.
But the idea is there could be different transports, and one of those might be Ultra Ethernet. UA link. Too
Right.
many ultras.
Yeah, yeah. Okay. And I also noticed, Intel talked a little bit about Crescent Island as a new GPU or GPU based product. And just my thoughts. When I looked at their slides from OCP, they hit a few high points. They talked about open software and enterprise form factors and heterogeneous hardware. So, I interpret enterprise form factor to be, not a rack, but maybe more like an add-in card or something more, something much physically smaller and much scaled down compared to a rack. Is that, is that your interpretation?
Not quite, because they also talked about their ability to use Gaudi 3 as kind of a front end to NVIDIA in inference,
Oh,
where Gaudi 3 is doing the prefill stage, and then NVIDIA is doing
okay.
decode.
So that's kind of, okay. So is that like similar to the NVIDIA RTX story that we talked about last episode?
E- Exactly. So similar to the Rubin CPX story,
Right.
Intel's now saying, well, if you're going to use something different for prefill, you can use Crescent Island, which is going to be optimized for prefill and uses LPDDR instead of HBM, and so that's how they're positioning Crescent Island, I think. And yeah, it was announced at the event.
But are they saying for now you could use Gaudi 3 for that pre-fill stage?
I think basically the Gaudi 3 experiment is more of a proof point, and they're trying to maybe get people thinking about the fact that you can have heterogeneous architectures for inference, where you're doing
Right.
prefill with one architecture and decode with a different architecture. So my impression is it's just kind of laying the groundwork for Crescent Island.
Okay. I mean, frankly, I think they've struggled to move Gaudi 3 silicon, and everybody has struggled to take on NVIDIA. So, this is just sort of the best shot they've got with what they've got in terms of Gaudi 3, and then, hoping that they can kind of get a, get kind of the nose in the camel's tent with Crescent Island or something.
Yeah, and the time frame basically matches up with Ribbon CPX. So it's kind
Right. Which I erroneously called RTX because I suspect that they're rather similar.
of
Um,
exactly.
and that time frame's a year out. So, I mean, think about it. We're recording this in October, and a year ago, nobody had heard of DeepSeek. And for example, like, and that's sort of like that's a distant memory. So a year from now, who knows what the AI world will be concerned with.
Yeah, I mean, I think from a messaging standpoint, Intel is trying to point out that agentic AI will have a diversity of needs from kind of front end processing on CPUs to LLM prefill on GPUs that are optimized, that are more compute optimized, to LLM decode on more
Right.
memory optimized GPUs, to even they even mentioned DPUs and IPUs. So I think if you're Intel, you want the world to look heterogeneous, right?
Well, yeah, I mean, if it can't be homogeneous using your product, kind of the next best thing is heterogeneous where your product at least has a play.
Exactly.
So, and as for the agentic, that's the buzzword du jour. But I think there is a lot of interest in, particularly for like the cloud-based inferencing. But it could be scaled down as well as having a front end router that when presented with a query or a workload, it knows to route it to like the biggest kind of the biggest, most complex model, or the reasoning model, or a smaller model, or an even smaller one yet. Because the practice of just throwing every query at the biggest model is it just uses a lot of compute, and it's just not cost effective for these AI services companies, and it won't be cost effective to anybody self-hosting. And then I noticed Crescent Island uses LPDDR5X, so the total memory is about the same as HBM in some of the current generation chips, about at 160 gigabytes. I'm assuming they did that because it's relatively low cost, and so you get a lot of bandwidth because you're using a lot of LPDDR5X chips, and they're relatively cheap and low power. I think the other alternative would have been to look at GDDR, which has more bandwidth per chip, but I believe it's more costly, and it's also a lot less power efficient. There's a lot of, the run to fast interface, they chew up a lot of power.
Yep.
All right, well, we'll see what happens 12 months from now. I think, as I said, the world's going to be a different place.
Absolutely. So I guess the other big recent news, which kind of, well, there's been so much news, it's been a little bit even hard to keep up in terms of the AI investments and deals that have been happening. But the AMD OpenAI deal was certainly a big one. So what exactly did they agree to?
So, well, some of the details are withheld. It's one of the first things I did was I went to the SEC page and pulled up the U.S. investor regulatory body, and I pulled up some documentation, and there's certain things that just like that aren't there. They've obviously been redacted. But the basics are OpenAI will buy AMD accelerators, and in return, it will get AMD warrants. So a warrant is like a call option, so it gives the holder the right but not the obligation to buy stock. But unlike a call option, new shares are issued. So when OpenAI cashes in its warrant, AMD has to issue shares, which means warrants are dilutive. So, if you had, say, 100 shares before the warrant, and then someone has warrants for 10 shares, you're now dividing the ownership amount among 110 shares. So everybody's stock value per share went down like 9%. I think in this case, it's not really an issue because Sam Altman's the ultimate hype man, and one of the conditions for the warrants, they're kind of two big conditions. One is they have to buy the GPUs, and two is AMD's stock has to go up. And so, Sam Altman's the ultimate hype man, so he he has every incentive to talk up the share price and to take action. And certainly, if the AMD GPUs are meeting OpenAI's needs, that's good for AMD, and that's ultimately good for the shareholders. So I think it's a good deal, and it certainly boosts AMD's credibility as a GPU supplier. That hey, OpenAI is going to buy a tranche of these, and that's it's sort of every company's been trying to create an alternative to NVIDIA, and AMD's really been the most successful of the merchant suppliers.
Yeah, no, it's huge validation for AMD, and I think it finally moves the needle, and also should kind of move the needle from a pure volume perspective as well. So
Yeah, I mean, I think the first shipment is like 50,000 GPUs, which, I mean, that used to be a lot, but now they're talking about million GPU data centers, but it is a lot, and it's a big deal. And I think also it, it's telling other customers that, like, hey, if this is good for the premier AI company, then these will be good enough for you. So should have some knock-on effects, I think.
yeah, the related piece of news was that Broadcom had announced a $10 billion new customer, ASIC or XPU
Right.
customer, and all the speculation at the time was that that was OpenAI, and then it just came out subsequently that in fact that was not OpenAI,
But
because
there is
then
another. But OpenAI is buying in for another whatever
for a much
chunk.
bigger
So
number. So yeah, so
yeah,
OpenAI is kind of spreading it around.
spreading the love. But I do one. There's been a lot of talk. Certainly, I've said this, and others have said this. It's sort of a lot like the circular financing and vendor financing of the telecom boom. There is a key difference here in that at least I'm seeing a lot of contingencies. And so, NVIDIA invested in OpenAI, but there are contingencies associated with that. It's not like they're writing $100 billion check. It's like as if they could, but they're not doing that. So I think a lot of it is OpenAI is lining up these suppliers and these deals and has this dream. But what actually gets deployed is, of course, TBD. Um, but so I think that's a key difference in that it's not the money is moving is indeed circular, but the money isn't. It's gated. It's not like the money's actually flowing right now. It's more like the deals are being set up, and if for some reason things go in a different direction, that the whole sum isn't spent. Things will just reconfigure.
Yeah, I mean the other thing is gating a lot of these deals is just the infrastructure build out I mean, they're gigawatts basically,
Right.
right? I mean, you don't build 6 gigawatts overnight. Well, we've gone from, like chip capacity limited to power limited, it seems,
So we've gone from tops and flops, right,
to
to
gigawatts.
gigawatts.
Yeah.
So it's a very strange way to think about technology. That the metric isn't number of pieces or amount of computing power, but power, like literal power, gigawatts.
Yeah. I mean, next year things are still somewhat gated by availability of um, foundry capacity, especially CoWoS capacity. But I think, you know, the bigger picture is definitely about power, and now, we see people building these distributed data center facilities to help deal with that problem.
Right. And actually, that's another thing about these deals. They're not only are they gated, but they do have a time element. So we're talking, 5 years or what have you in all these deals. It's, the deals are getting structured now, but the actual deployments and implementation is spread over time.
Yes, significant amount of time.
Okay, well, that should wrap it up for today. For more information, please go to wheelersnetwork.com or xpu.pub. If you found this video interesting, tell 4 friends. Questions or comments, put them below. Until next time, be well.
It's all about the pendients, baby.